Good evening, good evening, good evening. Ladies and gentlemen, WeatherBrains episode number 893, the world's oldest continuous running podcast about weather. This is the pre-show. It's the magical time of the program where we do three things. We share boring personal stories, humorous anecdotes, and from time to time we say really outrageous things. So we're here, and it's Monday, the 27th of February. So let me get the embed code going really quick, and we'll bring in everybody. Obviously, we got a lot to talk about tonight. Had a pretty significant severe weather event at this time last night in Oklahoma, parts of Kansas, and extreme North Texas. We're going to try and deconstruct that, the warning process, the event. A lot of comments in the weather Twitterverse today about some people saying they didn't get any warning, but the warnings were good. And it's just one of these hard things to deal with. It's a nighttime QLCS with embedded tornadoes that don't last that long, and they come up really quick. And you just can't provide the lead time that you can for the more traditional type events they see there in the southern plain states. And we deal with this stuff all the time here. It's hard. And, I think what we need to do is just learn from what happened last night and look at what could have been done better, what was done right. And we all need to learn from that. I absolutely love case studies. That is the only way we can get better. It's to look at events like that. But Kim will be on the show tonight, and hopefully Rick Smith can join us. Rick might be a little late. Of course, Rick and Kim were both in the middle of it. Actually, Rick was not in Norman at the time. He was at a state emergency management conference in Durant, Oklahoma. So he was not at the forecast office. But again, obviously, he's been there throughout the day today doing storm surveys, and hopefully he'll join us a little late, but he should be on the show. Dr. Jacobs will be here. And again, we're going to talk about that in the second hour after we talk with our guest, who I cannot wait to hear tonight. He's going to be really good. Had a chance to hear him speak at Ohio State a few weeks ago. And, every once in a while you go to these conferences and you hear somebody speak and you're thinking, we got to get this person on the show here. And so that's the situation here. Bill Murray is out. He's actually not at 50-cent beer night at Hooters for a change. Bill had to have a little medical procedure, an emergency appendectomy today. So he is going to be out tonight. And, of course, we'll have James Adelot on the show. James obviously was in the middle of it in Tulsa, the event last night. And, again, what I try to do in a situation like this, and I like to watch other meteorologists around the country that do long-form tornado coverage and just learn best practices from them. Would I do the same thing they do? No, but I don't understand the culture in other markets. That's not what I do. That's why I've said this over and over and over, but it is so true. You cannot effectively do severe weather communication unless you understand the people, the culture, the geography, and the microclimates of a market that you serve. And so by transplanting a James Spann into, Oklahoma City or Wichita or Denver or Boston or Chicago, yeah, I could do it, but it wouldn't be that good. I mean, it would take me a while to learn the things that you need to learn to be successful in other markets. And that's why I think for people that have stayed in a certain market, whether it's for a National Weather Service office or on the television side, that's a really good thing. And again, there's nothing wrong with moving, but again, there's just something to be said for hanging out in the same place for a long time because you do begin to learn the people and what they expect from you and how to serve them better when the weather is life-threatening and you understand analogs and history and you've worked many events, and it's just a good thing. Jen, I'm preaching. I'm sorry. I'm just sitting here by myself, just yakking away.
No, preach it. What's going on?
So how did you survive the storms this morning?
Yes, things were okay up this way. We had a couple of tornado warnings getting closer to Dayton, and yesterday was busy, not just for the Oklahoma people, but I was in Kansas, and that got a little interesting near Wichita and Hayes out that way. So, but yeah, I survived and things are going good. I do have a quick question. Are you sending the invite?
I was about to ask you the same thing because I have not. I just sent the invite to the regulars. So
Okay. I've got his email. Let me send it.
yeah, that would be good because it's 57 after, and he's probably wondering where's the invite. No, that guy was so good.
He was great.
At that
Yeah.
conference. Sometimes you just, and they were all good, but to me, it was, I don't know, a practitioner doing what we do. I think there's some really practical use for GLM data, and I think what he's going to talk to us tonight about is going to be good. So we'll have Scott on, and again, this is the pre-show. By the way, this is where we share boring personal stories, humorous anecdotes, and we say outrageous things from time to time. But Scott is going to be with us on the first hour, and hopefully he can stay for the whole show. And then the second hour will focus on the event last night. And I think by then we'll have Kim and hopefully Rick to kind of, this. And I've learned after these kind of things, everybody just wants to talk. And there's some comfort to me in talking to your colleagues that understand what you experienced. And sometimes you just need to talk, and we'll just let them talk. And if they don't talk, I've got 10 gazillion questions about last night.
That sounds great.
Neil, do you know Scott at all with Nesdis? Okay.
Yep.
I heard him speak in Columbus, and I just thought he was outstanding.
He's great. Very, very interesting topic. So.
Yeah.
The GLM is a super cool instrument.
And I don't think we make proper use of it down here on our end. And what he shared up there was just really good. And I thought he could kind of go through that, and we'll put him through the ringer here. Here comes Dr. A from Tulsa. And again, Bill is having a little procedure. He'll be back with us next week. But this was an unscheduled procedure. But I happen to have some connections with the institute in which he's having this thing done. So I'll be sure that he's taken care of. What's so strange about that healthcare thing, and I've always been interested in medicine, always. But it was supposed to be a very temporary hitch. That they wanted, a friend of mine wanted me to sit on the board of this hospital group. They're going to sell it in a month, and he just needed a warm body in there. And he was fired a week later, and they decided not to sell. And hello. So I was kind of stuck on the board, but it turned into something I was very interested in. And so I have been doing that for this year will be 18 years. It's just a volunteer. I'm like a candy striper wearing a suit. But and I will say this, if you're doing what we do, you will learn a lot from talking to ER docs. And goodness, in 17, 18 years, I've had so many discussions about blunt force trauma. What can I do to help prevent loss of life during a tornado? What better messaging can we talk about on the medical side? And obviously the biggest thing that came out of all that's the helmet thing. Where really I thought about it, and some people had used helmets in the past, but I just didn't think of that as being, a standard practice. But I immediately learned that it needs to be a standard practice. James, did you survive last night?
Yeah, it was relatively calmer compared to central and western Oklahoma. So, we had some tornado warnings, and we got to shake the rust off of doing a little bit of continuous coverage and tag team weather and QLCS whack-a-mole. But
whack-a-mole.
It was a little busier than I wanted it to be.
Mm-hmm.
And again, we had this bust here a week or so ago, and I tell everybody, look, we needed that run through. We needed just to get up and running, and like you say, get the dust off everything and look at the systems and be sure they're all working. Hey, Scott, can you hear us okay? We're not seeing your video.
There we go. I'm joined now.
There you are.
Yeah.
Hi, Scott.
Hello.
Scott, you were so good at that Ohio State thing. I had to get you on the show. So thank you for coming on.
Well, thank you. I appreciate you having me.
And we're not recording yet. And just so you'll know, we're live on YouTube now, but most people listen to this, and that'll be released later tonight. And Scott, I don't know how much time you have, but if you can stay for an hour, is that possible?
Yep. Yeah, I'll be here. I think my wife's going to put the little ones down, so I'll try to stick around for the whole time if I can.
Yeah, and I was going to say after the discussion with you, we're going to morph into the Oklahoma situation last night with Kim and Rick Smith, and go that way. So, but Jen will be introducing you.
Yeah,
and,
Scott, can you say your last name so I will mess that up?
Yeah, my last name is Bridlowski.
Bridlowski. Okay, got it. Thank you. And then after that, I'm calling you Dr. Scott. So
There you go.
Dr. Neal and Dr. Scott.
Yeah.
Yes. All right. So let me get the recorder is going here. And all right, here we go. In 5, 4, 3, 2, 1.
Join the American Meteorological Society by becoming a member of the band. The AMS Weather Band is a global community of weather enthusiasts dedicated to learning and sharing their love of science. Visit amsweatherband.org to learn more and join the band today.
WeatherBrains episode number 893. This is the weekly show that's all about weather. For the 27th of February, 2023, kind of morphing from winter towards spring. And we had some spring-like weather. James ate a lot in Oklahoma last night. You say you came through unscathed in your neck of the woods.
Yeah, a couple of tornado warnings. I think 5. But boy, they had it bad in central and western Oklahoma. And did you see the Mesonet report from the eastern Texas Panhandle? I think it was Memphis that had the 114 mile per hour straight line wind measured.
Yeah, the wind fields were screaming with this thing. I mean, goodness gracious, the whole thing is very interesting. And again, for those that are watching us live or just listening, we're going to focus the second hour of the show on that event. And Kim and Rick should be on by then, who were right in the middle of it, obviously. So again, just hang tight. We're going to talk about the event in Oklahoma last night in the severe weather situation. But I see Troy Kimmel down in Austin, Texas. Troy, that stayed all north of you, I assume.
Yeah, it stayed all north of us. We ended up to 83 or something this afternoon. Yeah, 83 out at Camp Mabry, mainly the dry air dew points down close to 12, I think, this afternoon. So that was some of that dry air in place, and wait for the next one. But so far, what we're seeing is they seem to have James's name on them there in Oklahoma, or folks in central Oklahoma. Was that these systems look like we're going to stay on the dry side. I just don't see much in the way of rainfall over the next 7 days, even though there is some chance midweek with another upper air storm system. But again, I think the main effect is going to be north of Austin.
Yeah, and this one, the system that affected Oklahoma last night, the dynamics went up toward Jen's country, and just way north of here. This ridge has been so strong for so long, but it looks like we're going to be in a situation somewhat similar to Norman and Oklahoma City by the end of this week, probably Friday morning. This is going to be one of these nasty early morning QLCS events that will be a very rude wake-up call, I'm afraid. And this is something that might come through here where I am about 4, 5, 6 a.m. Friday. So we'll be talking about that later. Dr. Neal Jacobs. Dr. Jacobs, you are in North Carolina tonight.
Yep. I'll be in DC for the next 2 weeks after this, but I got my weird weather deflector shield up. I mean, there's been nothing going on here. It's the rest of the country. It was actually kind of nice, like almost 70 degrees.
A lot of buzz about a pattern flip in mid-March and the East turning cold latter half of March.
Plants aren't going to like that. They think it's April already.
CPC put out one of their statements with key messages Friday about the pattern flip, which I don't think I've seen one of those before. Talking about sudden stratospheric warming and the analogs and potential for a big pattern change. So we'll see. It's all I can do to figure out the weather tomorrow. But Dr. J, hang with us. Jen, let's bring in our guest. I'm very excited about the first half of the show tonight because Scott's got some great stuff to talk about. Go.
Absolutely. Yeah, we got the opportunity to hear Scott speak at the Ohio State Symposium just a couple of weeks ago. And so, Scott, thank you for being here. Let me do your bio and tell everybody who you are. Dr. Scott Bridlowski is a Noah Nesdis physical scientist who splits time between offices at the University of Maryland and Kent State University. Dr. Scott, who I'm now going to continue to call him so I don't have to say his last name and mess that up, graduated from Ohio State University I will not hold that against you as a Penn Stater. In 2004, Florida State University in 2007 and 2011. As the science lead for both the GOES-R and GeoXO lightning mappers, his work helps ensure the availability, understanding, and application of lightning data from both ground and space-based observing networks. His NOAA position has provided the privilege of mentoring dozens of scholars at various stages of their high school, undergraduate, graduate, and postgraduate studies. So Dr. Scott, thank you so much for being here and giving us some lessons on lightning.
Yeah, thank you so much for having me. It was great catching up with you guys at that Ohio State Symposium. And it was one of the few venues where I go, and I just knew I wasn't going to be the most energetic on stage. James obviously took that title. But yeah, it was really a nice program that day.
Yeah, it was great. Your presentation was awesome. So we're going to kind of get into that a little bit more, but we want to start out with just as we usually do with a lot of our guests, take us back to the beginning. Why did you even get involved in weather, and how on earth did you end up in lightning?
Certainly. Yeah, it wasn't direct until it was. So I started, as you said in my bio, at Ohio State. I was going to be a rocket scientist, aeronautical engineering, and at the encouraging of my father, and then realized fairly quickly that I should go into my passion, and that's meteorology. I was always the kid sitting in front of the Weather Channel, even over at friend's house. Always knew kind of that's what I wanted to get into. So once I got into it, I really took a liking to it and applied to a number of graduate schools. It was really between Texas Tech and Florida State, and I decided on FSU, where I was a teaching assistant for Henry Fuelberg my first semester. Just wonderful. Ended up being a mentor of mine during graduate school. Sitting in his office when he received a phone call about a project and told him I'd like to work on it, and that's how I got into lightning. So it was kind of serendipitous in that way. But if you move to Florida, it's more than likely than not, you're going to end up studying hurricanes or lightning. And so it was pretty natural for me to end up in that field.
Florida State was my first choice, actually, because we lived in Florida and I was obsessed with hurricanes. And so I would have liked to have gone there. But then we found ourselves in Pennsylvania. So I found a different route to take there, went to Penn State instead. But Florida State's an awesome school. Talk a little bit more about your position now and going through, in your bio, it talks about ensuring the availability, understanding, and application of lightning data. So talk a little bit more about what your role is and what all that means for us.
Yeah, I guess maybe to finish the second half of that story, we'll answer that question. So as I was at Florida State, I finished up that project for my master's, and the lead scientist for the GOES-R program, Steve Goodman, was looking for somebody to work on lightning. And so that's what I did for my PhD. And almost from that point was kind of, being, I guess, groomed, for lack of a better word, to be the person for that position. And so then I moved up to DC to do a postdoc with Steve, and he was actually moving back to Huntsville at the same time. So I ended up a little bit on an island up there on my own, but I kind of knew what I wanted to do. And a NOAA position opened up right on the same floor at the University of Maryland at a cooperative institute. And so I applied for that position. It didn't say anything about lightning in the call for applicants, but that's what I studied. So I applied. It turned out that was on the NOAA strategic hiring list. They needed somebody with lightning expertise. And so even though I didn't fit the description for the position, I ended up being hired for that. And that was after only maybe a little less than a year at the University of Maryland. And so I've been in that same building ever since I left Florida State. And that's how I ended up in kind of the NOAA position and as the science lead for both the lightning mapper on the GLM, which was the first of its kind. It launched in 2017. We now have 3 up there, but that's a full-time job on its own. But we also have to keep planning for the future, and so that's where this GeoXO program. It's the follow-on to GOES-R, and as things are planned right now, the intention is to have a lightning mapper, and so there's a lot of planning that needs to go in to do that. So those 3 things that you listed, assuring the understanding, the application, and the availability. That's for both of those programs, and it's really a lot of what we do.
I've got a bunch of questions. Hey Scott, it's good to see you again.
You as well.
It's I guess for those of you who probably aren't aware or haven't seen it, the Weather Act of 2017 actually requires NOAA to do value assessments on instruments over 500 million, and it also requires NOAA to do an Aussie and a simulation of what future instruments would be if the life cycle cost is over 500 million. And that report that you put together was one of the coolest things that came by my desk that I had to clear. So hopefully I didn't take too long getting it up through DOC. I want to talk a little bit about some of the observation capability, particularly with forest fires and other things that you can do besides just what people would expect with lightning. And then after that, I want to dig into some of the other things with GOES, and I've got some questions that I think might be interesting for the listeners. But tell us a little bit about the instrument itself and why it was so cutting edge.
Yeah, great. A great way to introduce the GLM. Good background there. The GLM is the first geostationary instrument to detect lightning. We've had low Earth orbiting instruments on the Tropical Rainfall Measurement Mission, and we actually have the backup lightning imaging sensor on the space station right now. And so those detect the optical energy that escapes the light top or the cloud top. And so it's able, with a lot of detail, with very rapid updates, it's able to map out the lightning. So on the low Earth orbits, you just get a maybe 90-second snapshot as it flies over. And so it takes, you might see a certain place on the Earth once or twice a day, whereas the geostationary lightning mapper is always constantly staring at a giant area. It's, probably 90 to 95% of all the lightning in the Western Hemisphere is seen by the lightning mappers, the combination of the two. And so that's why it's revolutionary. It kind of takes that low Earth orbit insights and it takes it up to geostationary. So you have it full time, all the time.
So I guess it was, which GOES was that? That was March of 2017 that one launched. Yep. That was my third day on the job at NOAA. And I went down to Cape Canaveral, and I don't know if you remember the discussion, but they were trying, there was some range potential conflict between the NOAA launch and an Air Force SpaceX rocket. I had been there for like 3 days, and they were like, hey, can you call Elon Musk and see if he can get SpaceX to stand down, because we got the Secretary of Commerce on his way down here to watch this rocket launch.
Whoa. This is a good story now. So did you talk with Elon Musk?
No, we got range preference anyway. And it was like one of the few launches that went exactly on time. It was pretty great.
Wow. Dr. J has some pull right here. That's all I'm going to say.
But that was cool. I mean, I do want to talk a little bit. Well, I'll just ask a question now. We'll skip ahead. I'm just curious. So when the ABI had the issues with the loop heat pipe, and they were doing all those yaw flips and all that other stuff, did that mess at all with the GLM, or were you all just along for the ride?
Yeah, we were along for the ride, so just more or less. When they do a yaw flip, our field of view isn't 100% symmetric, and so they do yaw flips actually twice annually as part of the GOES planning. But when they do it more frequently, we have to pay a little bit more attention as to where the instrument's seeing all, so there's a little sliver of the US and a little sliver near New Zealand that isn't covered in a certain orientation. So we have to watch that. But it is interesting because the GLM is so sensitive that if there is any disturbance at all to the platform stability, we can get a bunch of false detections all at once. Like if the clouds look like they move at all, then all of the edges light up. And that doesn't happen much anymore, but they have a series of, calibration scans that they have to do for some of the space weather instruments. And we know when they run those scans that we're going to get some false events. So we put out notification. But yeah, so we are sensitive to the other instruments, but the heat pipe didn't really cause us any trouble.
Go ahead, James.
I have a really dumb question. How did the concept of detecting lightning from these orbital sensors begin, and how was the sensor developed? Because I would think, you're going to have a lot of lightning flashes initially as this technology is developed that are just missed by the sensor for time step reasons or sensitivity reasons. But how much of that lightning do you think you're catching now? And how has that evolved since this first began? And when did it start?
Well, let me ask a question too, Scott, while we're here, because it's going to tie back to what James is asking you. Scott, thank you for being with us tonight, by the way. While you're answering James's question, for the folks that are out there listening to us or watching us, we're sort of used to the ground-based triangulation system, which we have in the U.S., which is owned in the private sector. And this is completely different. This is not looking at, it's basically flash density, right, from the satellite. So I figured that would tie back. Yeah,
it's even more detailed than that. We
Okay.
see just the itty bitty bits and pieces that we then string back together into these massive lightning flashes.
Okay.
So yeah,
And
it's a
I'll let
lot
you-
of detail. Yeah, it's a lot of detail. And most users don't need that. So what many users will see is what's called a flash extent density. And that's probably what you might be referencing.
Yeah.
That's just a count of how many flashes occurred over a given period of time within a grid cell. And so by looking at that, forecasters can trend the thunderstorms and get a better idea whether they're intensifying or weakening. And so that's the one of the main uses of it. And you can do that from the ground-based network too. So as you mentioned, as James mentioned in his question, the ground-based networks, they've been around, NLDN kind of late 80s, early 90s. It's been expanding since then. Earth Networks has come on the scene in the last decade or so, and they have a really nice product too. And so it's a completely different technology. But
Okay.
forecasters, once the forecasters are trained in how they can use the data, they see them as very complementary, and they fill each other's gaps, and they really help round out the application. And so that's really been our message: is it's not an either or. You really need both to get a full picture of the story, and that does kind of provide the necessary context to get back to James's question. The idea of detecting lightning optically from space goes back to the beginnings of the space race, and the idea of when you see lightning, you take a picture, a photograph. Can't you do that from above? And so they did some test flights with the ER2 and other high flying aircrafts above storms, and that's really how they detected the optics and how they decided that it was 777.5 nanometers. That's the wavelength where it's one of the peaks where lightning makes the most light. And so they found that out back in the 70s. They've known that for a long time. And so they started just, how are we going to build a geostationary lightning mapper? And that doesn't happen right away. It takes 10, 20, 30 years as it turns out. And so an obvious step is to build a lightning instrument or a low Earth orbiter. That's, actually the Australians are exploring that right now. They're looking into potentially having a geostationary lightning mapper. And their first step is scoping out a low Earth version and seeing if it's something that will fit within their program. And so once they had a mission, the Tropical Rainfall Measurement Mission, they designed the instrument, and they made two of them back in the kind of late 80s, early 90s. And one of them went on trim, and it lasted way longer than it was supposed to. That was one of these, it's supposed to be a 5 to 7 year mission, and it lasted almost 20, long time. And just as that one was going offline, there was a call for projects. The space station, they were looking for instruments that could be hosted. And our colleagues in NASA Marshall Space Flight Center put in a proposal, and they said, hey, we've got this spare Liz that's been in storage. Can we put it on the space station? And they agreed. And so it's been there almost since the trim lost. I forget exactly what year, but it was about a year gap from when we lost the trim to when the ISS Liz. And we've had to move it once or twice because other instruments have come up and taken priority. But that's really the story of optical lightning detection. That's how we got here. To what we have.
When did we get really good at this?
In terms of detecting it, it really was with the GLM. The stuff they were doing was the first time it's been done. Some of the electronics that are on there, the focal planes, it's just amazing the technology that goes into it. And that's, I'd say we got really good at it after the first two GLMs, right? So we had two up there, and we learned some lessons, and they actually able to make some engineering changes, small ones, but they were able to make engineering changes and improve the next two flight models. So the one that's currently the GOES 18 GLM is our best performer, and the next one that launches will be just as good, if not better. And so, yeah, we're still learning. It's that new that we're finding out things now that we couldn't have anticipated, and we're improving it. We're doing tests on the GLM this year to get an extra 1 or 2% detection efficiency, because that's what we found out we can do. And so it requires a little bit of a disruption to the products coming out. So we make sure the Weather Service is on board. And once they sign off, then we go ahead and do that testing and implement those changes. So we're still getting better at it, but we got good, I'd say, after the second one.
I want to talk a little bit about the forest fire initiation stuff and the TC intensity. But before I do that, can you just talk a little bit about the current coverage and field of view of what's existing with the GOES, and what might we expect from GeoXO in the future? Yeah,
so presently we cover, with the two of them, we have a significant overlap period right in the center of the US, and it's more or less symmetric. So it goes to 54 roughly degrees north and south. So, up into Canada for a good ways. And then east and west, it's almost to the coast of Africa on the east side. And then all the way to the west, it's to New Zealand. We actually see some lightning in New Zealand. So it's that vast of an area where we have these, this total lightning coverage.
What about the GeoXO? Is that?
Oh yeah, the follow-on GeoXO, it's TBD. So there's we're still in the planning phases, and ideally, this was the same case with the GOES-R. Ideally, we'd like to have coverage of Alaska, but to do that, if it requires too much additional cost, then it's not gonna go up there. So I think they're still at the stage of seeing whether extending the geographical coverage fits within the specs, or if something needs to be done that makes it cost prohibitive. So it's still to be determined if it'll be any broader. I think it'll be at least the GLM, but maybe a little bit broader.
See, this is one reason why I've often argued that NOAA really needs to dig in more on the return on investment for these instruments, because a lot of times they produce these amazing instruments and push data out and don't really do a sort of a, what was the cost avoidance of various issues. Like, for example, I personally think this thing more than paid for itself just in the ability to detect forest fires quicker. I'd heard several cases where they were being reported off observations that Nesdis was providing before they were even seen by spotters on the ground. Can you talk a little bit about the forest fire capability?
Yeah, and that's a great way to lead into it as well. So you mentioned the value assessment we did as kind of the initial stages of planning for GeoXO. They had a group of scientists do a value assessment of the GOES-R as a capability. So all the instruments, the ABI, the GLM, and they went through, and one of the applications they looked at was wildfires, and a bunch of different numbers went into estimating it, but they estimated 88 wildfires were prevented each year because of the GOES-R technology. They were focusing mainly on the ABI. They hadn't taken the GLM into account directly, but just getting those 88 fires, if you do all the economic analysis like they did, that's somewhere between 100 and 500 million annually that you're saving or preventing in terms of losses if you're able to put out those fires. So just that one application, that's a 20 over the lifetime of it, that's a $10 billion application if you just extrapolate across the program's 20-year life cycle. And so that that's a huge advantage. And so a lot of what I've done since that value assessment and the kind of the science time I have is trying to dig deeper. The value we provide for the fire weather application, for filling radar outages, filling radar coverage gaps, the outages, and where you just don't have good coverage, and also the aviation application. Those are the three that I've really been trying to actually get quantitative estimates. It's a very difficult thing to do. But going back to the wildfire application, it's a really good way to introduce kind of what the GLM does. And there's three main things where it applies. The first one is it's kind of a new technology. It's able to see the continuing current in lightning flashes. So ground-based networks will tell you the polarity. They'll tell you how strong the flash was in terms of the estimated peak current, and they'll tell you very precisely where it struck, but they won't tell you how long that current stayed flowing down that lightning channel and into the ground. And it turns out that's a really important parameter when you're trying to determine if a fuel is going to catch on fire. And so what the GLM does is it shoots 500 frames a second. So it has 2 millisecond resolution. And it can look at that lightning flash and see how many continuous 2 millisecond frames are lit up as part of that flash. And by summing up those, we can tell you how long that lightning flash lasted. And the longer it lasts, it's not a great analogy, but I remember from back in grad school, they said it's like putting your finger on an iron, right? If you hold your finger there longer, it's going to get burnt, right? And so the longer you hold it there, the more burn it's going to get. Same idea with a lightning flash is if it's in contact with that fuel longer, it's going to cause fire. And so that's the number one application of the GLM, just because it's in my mind right now. Sorry, I got to get a drink of water here. Once I start talking, I get dry mouth. But anyhow, the positive and negative has always been known to cause a difference in fires. And the reason is maybe 95% of lightning flashes take negative current to the ground. Roughly 5% take positive current to ground. Negative flashes can't have high peak current and long continuing current. When there's a long continuing current and a negative flash, it's a low peak current. In positive flashes, you can have high peak current and long continuing current. It's that combination that makes them, pound for pound, more destructive, more likely to start a fire. And because there's 95% negative, they start more fires, but the positives, when they do occur, are more dangerous. So that was all a discussion of just the one part, the long continuing current. The other one is the better detection and characterization of pyrocumulonimbus, or fire-generated thunderstorms. And those are very dangerous. So when you get these fires that are intense enough, there's enough moisture and heat there that they can generate their own thunderstorms. And that's very dangerous for firefighters, both on the ground and the air resources that they bring in to fight the fires. And so on the ground, if you get a thunderstorm, you get inflow and outflow. And so it can change the fire's direction rapidly, very quickly. And same with the flights. If you're flying in to try to extinguish the fire, you don't want rapidly changing winds associated with thunderstorms. And a lot of times these fires are out where you don't have a great view from the radar. And so the GLM and the ABI, that might be your first idea that there is a pyrocumulonimbus developing. And so that's a very important application to help keep firefighters safe. And then the third one is kind of along the same lines, but it's the idea of where these fires are occurring, you don't have great radar coverage. And so the satellite resources become much more valuable to those that are fighting the fires. And so, a lot of work that's still going into that. I have 2 members of my team that are focusing on the fire weather application right now. We're looking to try to definitively say which lightning started each fire so that we can do some machine learning work and actually come up with a better model to predict where these things are going to occur.
How much of that can you automate in some sort of prognostic algorithms?
Yeah, a lot of it can be automated. If you try to link lightning with fires with an automated algorithm, you'll link 90 to 95%, but it's not all that precise. There's going to be some that it's closer in space, but it actually, it needed to be closer in time. And it's one that was a little bit further away that started it. So there's plenty of folks that have done that. What we've done is we actually used Python and generated some websites. It's just an automated script that we ran. And now we have tools to bring a human into the loop. So we have a zoomable map where we can zoom in and hover over the lightning flashes and get the time and all the other characteristics. And we have fire spread animations, just websites automatically generated, and then a form. And so we just go through and we can just fly through these lists and say, okay, that lightning started a fire, that lightning. And then now we're going to know very precisely to the minute which lightning started these fires. So that's where we can start bringing in the machine learning experts and the experts on the other data sets. A lot of times the fuel is as important. A lot of times the fuel is of a state that if there's any lightning, it's going to start it. So those 2 teams of scientists really need to work closely together.
I guess you've got a whole group doing like soil moisture and dry fuel content or whatever. This
Yep.
is such a cool way to solve a problem it's been such a major issue. So let me shift gears here real quick. I want to talk about cyclone intensity. There was a couple times where I was talking to folks at the Hurricane Center, and the models have notoriously, particularly in storms going up over the loop current or something, would be underdone in the models by one or two categories. And they would always express a level of comfort and sort of aiming on the high end of the spread based on a lot of the lightning imagery that they would see, or the signals as a proxy for intensity. Was that an expected use of this capability, or did it just sort of happen? And where are we with sort of using that in the data simulation and initial conditions?
Yeah, it was an expected use, and it was known that more science was needed. And so it's really encouraging to see the folks at the Hurricane Center and TAFB and other scientists down there really trying to figure out exactly what it's saying. So when I was at Florida State, and even years after that, there was a mixed signal in terms of what lightning meant in a tropical cyclone. For a lot of years, they compared the amount of lightning in the inner core versus the amount of lightning in the rain bands. And they did ratios of those two. And they showed if one was increasing and the other was decreasing, it said something about the intensity. But then you could find exact opposite cases where it didn't have that. And so it was kind of a simplistic view, but we understood we were kind of not blind. We had lightning data out there, but the ground-based networks are better over land. Once you get a ways out over the ocean, they don't resolve the lightning as well. Both in space and time, they have a little bit lower detection efficiency, a lot lower once you get way out in the middle of the ocean. But so we knew the data wasn't there to definitively answer what lightning has to tell you about tropical cyclones. And we were really excited about the GLM coming online, because then we would have total lightning data. And by that, I mean the GLM seeing intracloud and cloud to ground and the ground-based network. So we could look back through the whole archive now that we have the GLM and focus on the storms more recently. But that's really opened up, like you said, you witnessed the forecasters. They're using it almost intuitively. They're looking at it and recognizing what it says about patterns within the storm. And they're still working to quantify it. They have what's called a rapid intensification index, and they've incorporated lightning into that. And so that's one automated tool that they use, and it's one of the predictors, and it's one of the more important predictors in that tool. But it still hasn't been incorporated in more tools that they use for TC intensification. But where it is really hitting a sweet spot is the forecasters looking at a storm and observing how frequently the lightning is occurring and where at in the storm that lightning is occurring. And that tells them, is the storm being exposed to shear? Is there something changing dynamically with where that convection is favored that says something about the larger environment? And is there something that it says about the organization of the storm itself? Once, for instance, Ian, as it was making landfall, there was lightning completely surrounding the entire eye, a gigantic eye. And so that just showed how intense that storm was, that kind of eye was a feature, a single feature, even though it was a giant eye. And so, yeah, it's those types of signals that you can see. And that's how they use it. They try to use it to make extrapolations to smaller scales and bigger scales.
I think the great thing to me about seeing how they use it, and I get that it is somewhat subjective, is it's a solid argument for a human in the loop in the forecast process, because they just kind of know, especially after watching it. I think the more years and more seasons that they use this as a way to sort of, I guess, ground truth the intensity forecasts, is they're gonna be better and better with their operational intensity projections. Can you talk a little bit about I guess regular convection, not tropical, but like just regular severe convection over CONUS? I'm curious to know, and I could be wrong about this, but was it Vizsla that has this ground-based lightning sensing network, or might be another Earth Networks or something?
Yeah, both those two.
Did you use that in any kind of verification, or is there any, are you filling in gaps between that? What's the synergy between the sort of the in situ, whatever they're doing, and the GLM?
Yeah, there's a lot of overlap, a lot of synergy as well. So we certainly use the ground-based networks as validation. That's really our best source, other than when we have field campaigns where we can put our lightning imager on one of the high-flying aircrafts. That's our only one-to-one comparison. Other than that, we rely on the ground-based radio wave-based networks. So you mentioned the two Earth Networks and Vizsla have really dense networks within the U.S. They both also have worldwide networks, and where you go within the world, there's better coverage and poorer coverage depending on it. But they do have global observations. As I said, when you go out over the oceans, there's only so much light you can see that far away. It just doesn't make radio waves that go that travel that far in certain frequencies. So you can't see the IC flashes, for instance, out over the ocean with the ground-based network. But then you also have, in addition to those, you also have these much finer scale networks. We have what's called lightning mapping array networks, and they're detecting very high frequency radio waves, and they see per lightning flash, hundreds to thousands of the pieces of a lightning flash. So we have one in the mid-Atlantic area with sensors out at Wallops Island and sensors all around DC. And with that, we can see accuracy within 10 meters of where the exact lightning channel was. So we can make these really detailed 3D dissections of it. And so we use those for our validation too, because we want to know if the GLM misses a flash, we want to know what was it about that flash that caused us to miss it. And the LMAs can tell you that it was perhaps way low down in the cloud, or that you could look at a radar and see that there was a really thick cloud, those types of things. So yeah, we use the private vendors, and then there's a lot of science networks that allow us to look at the lightning as well.
So you mentioned at the start of the show volcanic eruptions and commercial aviation. Can you talk a little bit about how the GLM is being used for that market?
Yeah, in terms of volcanic eruptions, that was another one that was kind of an anticipated use of the data. The NESDIS has a product called Volcat, and it is an automated set of algorithms that's looking at all the active known volcano, and they're looking for when they erupt, and so they can alert aviation. And lightning data is one of the predictors, and so they've used the ground-based networks. But again, a lot of these volcanoes that are remote aren't well observed, and so you need every data you can see. And there's been a number of them where the GLM, along with the rapidly rising plume as seen by the ABI, were the first things to indicate a volcano was erupting, and it helped get that alert out sooner and to alert the aviation industry of the threat.
I don't know if the range went far enough. Were you able to detect anything from that Tonga eruption?
Yeah, that's a fascinating. It was a fascinating case. I think probably the most extreme natural disaster I've seen, since I've been around. It was just so intense. And yeah, the GLM saw the lightning there. I have a couple of different animations that we put together. One shows that as soon as it erupted, we saw a flurry of lightning. GLM saw hundreds and hundreds of flashes, and then none. And then there was none for a period of, I might mistake, but 10 minutes, maybe a little bit less, where 5-10 minutes where you couldn't see any lightning from the GLM, and then it started up again. But the whole time the ground-based networks were seeing lightning. So lightning was being generated that whole time. It's just once that plume got so thick that no light could get out of the top, we didn't see it anymore. But to me, in addition to that, initial explosion, what was most fascinating to me is to the east of it, I don't know if it was 100 kilometers or so, maybe 200 kilometers, a line of thunderstorms. When that shock wave, that pressure wave went by, a whole line of clouds turned into thunderstorms. And so it was like that 10 millibar shift was just enough to cause all those clouds to turn into thunderstorms. And to me, I've never seen anything like that. And it turns out that wave did that all around the world. That initial pressure wave, that pressure perturbation was enough to trigger thunderstorms, not just locally, but at other places, far greater distances away. So yeah, really fascinating. And especially to be able to see it in that kind of detail when it's that remote.
I remember seeing a discussion on the MAP listserv about the pressure obs from that wave. That was pretty wild. So I guess I don't know if everyone saw this. I think a lot of people did. There was a meteor that apparently or supposedly was detected by GLM a month or so ago. Do you know anything about that? I'm not expecting that was an intended capability, but it sounds pretty cool.
Yeah, we call that an unplanned benefit. So yeah, it was it's somewhat it was unplanned. It wasn't unanticipated. If you talk to the scientists, they were waiting for this instrument. They knew they were going to be able to see these things, and they still are one of the most excited groups of scientists to have this new instrument. So traditionally what they had is they had what was called the US government data set, and that was the only space-based meteor bolide observations that they had, and that was classified, and so they couldn't do a lot of good science with it. And so as soon as the GLM became available, I think our first publication was a meteor paper, and it wasn't a lightning paper, it was a meteor paper, and it came out really quickly after we launched. And so they've been looking at it closer and closer ever since. They go back to our raw data. They don't want they don't want us to throw anything out. They want to see everything because we try to filter stuff like that out. And they're able to see in great detail how these things break up. And so as scientists, they can get 3D trajectories. They can look and see where it came from in space, and then they can use that to validate their models. So they know if a rock came from a certain spot that it should be made up of this and it should burn up like this. And if it doesn't, then they need to reconsider their equations. And so then they can scale that up to much bigger objects. And it really does help to keep us safe. And so it's just really a fascinating application. There's like I said, a whole team that at NASA, Ames, they're all around, but that they have an automated, if you just search NASA and bolide, BOLIDE, you'll find the website, and they're all on there. It's a human in the loop, so they're 10 days late, but anyone that we've seen, you can go click on it and see how it burned up in the atmosphere. And then to finish that thought, the really useful application, like you said earlier, where the money's made, where the value comes, is when the Weather Service is answering phone calls after a really loud explosion or a bright light in the sky. And that happened in Pittsburgh the day after Christmas a year ago, and it happened in Houston maybe a month ago, and it happened in San Antonio a week ago. And it's happening more and more. And if it's overcast, it's a really loud noise that nobody knows what it was. And depending on the times, what's in the story that day, people can get really scared. And so they call the weather. Any Weather Service forecasters know people will call to try to find out what that was. And now they can quickly say, yes, with the GLM, we're able to confirm that's what that was. And so, yeah, it's probably once or twice a month now that's, and I don't know how you measure the value in that, but it really helps those forecasters and it helps the people that are calling in.
I'm glad you brought up being asked to archive the data, because I had one more question, and that is, if you're pulling in temporal resolution at 2 milliseconds, how big are these files? And what's sort of the downlink latency?
Yeah, it's a great question. And we report lightning on an exclusion basis. So we only report the rapid changes in brightness. That's all that's sent down. So the rest of the field is blank. And so it's only those frames. And it's 20 seconds is the latency. So it's continuously flowing, but from the time that the GLM sees a lightning flash to when that data is available to a user is 20 seconds. It's happening that quickly. And those data files are huge, but it's all relative. Those level 2 files are much smaller than when you look at all the ABI stuff together. And then we also developed this suite of products directly for the Weather Service. When we launched, the GLM data didn't really fit the way that we'd like for it to within the Weather Service. And so we came up with these gridded or accumulated imagery-based products. And those are a tiny fraction of the size of the level 2. And that's what's actually being distributed to the Weather Service is these gridded imagery products. And so it's, by the time it gets there, it's very small.
So Scott and Neil, the buzz right now is you two guys have the same voice. I mean, it's the same voice. I mean, we don't know if the listeners can tell one from the other, which is fascinating, but that's a topic for another day. So Scott, I'm your practitioner guy here, and I got a few questions on the practical side. I've got a lot of issues where I am. One issue is a radar gap, and you mentioned that. I have a sizable radar gap on the western side of my state. The radar beam is anywhere from 9 to 13,000 feet off the ground, very diffuse. It tells me nothing about what's happening down at ground level. And we've got a real problem there. So how in a practical way could GLM data help me with this radar gap problem?
Yeah, well, that's one of the kind of use modes that we've seen is forecasters with the ABI and the GLM. They're able to kind of extend the range of each of the radars. And so they can watch these radar signatures kind of weaken as it's moving away from one radar. But the GLM gives you a tracer. It doesn't matter how far it is from a radar. And so if the GLM keeps trending up, they can kind of fill in the gap, and they can say, okay, maybe my radar can't see that part of the storm, but the GLM is still indicating that storm's strengthening. So we better keep that severe thunderstorm watch, that severe thunderstorm warning out. And it helps you kind of pass between radars. And so when you know where your gap is, if you've got one coming, you kind of know where it's going to stop. And so you better watch the GLM trending the 10 minutes before that and the 10 minutes after, and kind of, it really helps the forecasters string it all together. And that's what we've seen kind of as a use mode.
So another issue, and we talked about this a little bit in Ohio, is air mass convection, random air mass convection in the summer. It is one of our biggest challenges. I cannot at 7 o'clock in the morning tell a human being when or where it's going to rain at 3 o'clock in the afternoon. The convection will be there. We know it, but we don't know when and we don't know where. So accordingly, I can't help the football coach when he's trying to do a practice. So convection initiation, how can GLM help us with that mystery we have?
Yeah, that's another one where we've kind of watched how forecasters use the data. We knew what we'd done traditionally with radar data, looking for certain reflectivity thresholds at certain isotherm levels and those types of things. But with the ABI, it has so many different channels that now, and we shoot in mesoscale mode a lot of the time when there's interesting weather. And so they have they call it day cloud. I forget day cloud. I forget the exact name of the RGB, but it's a combination, and what it lets you do is see the clouds glaciating. And so if you look at it, it's kind of a combination of blues and reds and greens. And the more green clouds are the ones that are showing more ice. And so the forecasters will watch this day cloud phase, I think is what the product's called, day cloud phase RGB, and they'll look for those clouds that might look the same invisible, bubbly clouds. But if you look at those other channels, you can see that there's now ice in that cloud. And so they combine that with the GLM to try to anticipate which parts of a line or which parts of a boundary might get convection.
This is just fascinating stuff. And the next question, how much of this data is available to, say, a WFO in Jackson, Mississippi, or Tulsa, or Memphis? What are they getting right now?
Yeah, so they can, if they ask, or they can get this level 2 data, the original stuff that came out, and that's the points where the flashes are, the flash locations. But that's not really encouraged because they don't need that level of detail. They need a different level of detail. And that's what these gridded products are. So it's been an experimental, but we haven't had a disruption in 2 years now. And actually just on March 6th, it's going to turn official. NESDIS is going to generate and distribute the products. But they're these accumulated gridded imagery products, and they provide additional information beyond just yes, no lightning. So I mentioned the flash extent density earlier. That's what a forecaster is looking at trends, and they're trying to see if a storm's intensifying or weakening. But we also have minimum flash area that shows you how big the lightning flashes are. So within the convective line, you'll have small flashes, and then back in the stratiform region, you'll have really large flashes. And that'll help a forecaster. We've seen cases in Oklahoma and other places where they'll kind of see the convective mode changing from where you have more of like an anvil setup. You have the isolated storms in an anvil, and it's shifting to more of a stratiform type convective mode. And that takes you from a hail and tornado hazard to more of a wind and flood hazard. And so they look at the sizes of the flashes to see what it, again, like we were talking about with tropical cyclones, it gives you clues about other things, bigger and smaller. And so that another one. And then we have total optical energy, is how much energy, how bright is the top of the cloud during that period of time. And kind of forecasters have likened that to watching a light bulb light up and dim as the storm strengthens and weakens. And there's other ones. There's 7 of them. Only 3 of them are going to the Weather Service right now. We're still developing use cases for the others.
See, to me, this is a treasure trove. It is an absolute treasure trove. And I know we have people that listen to this show that work for the weather company and Barron, and we need to get this data into our boxes on the broadcast. James, do you have access to any of this GLM data in your box there?
Not in the box, but we use a lot of the college sites with that in it to look at it. College of DuPage for one. I've got that up right now.
Yeah, we've got to get Barron, hint, and WSI, hint, to get some of this data. And I understand, like Neil was talking about, the goodness, the amount of data is just stunning. But these basic streams into our systems here, I think it's very practical. Scott, don't you think it's a practical use case we can show on television in visual form and help people?
Yep, and it's really the only spot we haven't gotten to that we need to. We've the Weather Service was first. That's our main customer. There's other folks that we've provided access to, but yeah, the broadcast community, it's such an important user, and this is a year that we've decided to focus on that, and so it was a real trip getting to see you at that meeting. So we got to talk about how this might happen. But I'm going to make a point of going to NWA this year and putting together a presentation. I think the idea is going to be to show the package. There's a lightning caster, a predictive tool that focuses just on the ABI, and it gives you a 60-minute prediction of lightning. What's the probability you're going to have lightning in the next 60 minutes? It's independent of GLM. It's just ABI. But then if you package that correctly with the GLM data, that there is a really useful thing, going back to your initial challenge of pulse convection, these daytime thunderstorms where they're going to happen somewhere, but where, and trying to get the heads up out earlier, before you hear thunder or see lightning. That's really the goal. And so I think that's with your help and the help of others, we'll make a point of that this year to get with WSI and Barron and try to make it happen.
We will make that happen because we know people, and we've got to make this happen because this is real world practical data that will be helpful to everybody. And we just got to be able to tap into this. And when I heard you speak, I'm thinking, wow. I mean, I just stopped in my tracks and listened. It was fascinating. All right, Kim, and welcome to Kim McLean, Dr. Kim Cloco McLean, who is now with us. She's got the kids to bed. And Kim, you got some questions for Scott, so you go.
Sure. Well, really just one quick one. And it's a great follow-on from all of the operationalization questions that you were just asking about, James. It's my observation that things in this world, especially to do with lightning as a phenomenon type, can be difficult to transition to operations, in part because we're not taught a lot about electromagnetism and its applications in our traditional coursework. We're taught a lot about other, kinematic, physical processes, dynamics. And you touch on, as you're describing these things, you're actually likening them to physical processes to help, I think, us wrap our minds around even what's happening. But I'm curious to know, from your perspective, how much do you think that we maybe need to think about shifting the way that we train to these new emerging tools? Is there more that we can do to help forecasters as they're coming up to understand the electromagnetism that's involved in anything to do with what you're able to do with a satellite? I mean, there's so much with it. And I mean, this could even extend to space weather as another place where I think that this applies. It's a whole other universe. And I feel like disconnected in some ways from operations, but we're really getting to a point with traditional operations and broadcast where we want to bring this stuff in. And I just wonder what the gap might be from your perspective.
Yeah, thanks. That's a fascinating way to think of the question. So that kind of extends to models too. We try to understand kind of what is lightning physically, how do you represent lightning physically in a model? And so they don't have a great way. The model doesn't resolve it. And so I think I see those two as similar, if not parallel to one another. With the humans, like you said, we try to introduce it with processes that they understand, as I said, with the hurricanes and with the thunderstorms. And it's a level of complexity that you often don't need to get into. You often don't need to get into the exact microphysics of it, but sometimes you do. And when you do it, it really it makes the training more challenging to put together. But it's worth doing. And there are microphysical things that if a forecaster understands what the lightning's saying, it will clue them into something that's of a scale that you can't resolve. And so that it's really powerful in that sense, but it's a matter of us communicating that properly. And so that's one way of kind of tying it in physical processes that they understand in the conceptual models. But then it's also just telling them the use cases, when to use it. A lot of, especially with the GLM being as new as it was, they just weren't familiar with using it. And so some of these applications I talked about today were news to a lot of people. And so just getting out there and presenting at conferences, putting together these talks, and that was very important then, and it continues to be important now.
Hey, Scott, again, it's almost the top of the hour here. So in a minute, we're going to kind of roll over into the Oklahoma situation last night. But I wanted to ask for people that just want to they want to learn the basics of this. What's a good online reference, a site where maybe they can go and just start to learn more about what we're talking about tonight?
I guess I don't know I don't know which site I would recommend you to. We have a few different ones. It depends if you want the imagery. Maybe I'll follow up with you with a couple of different links where folks could go to. It depends if you want to learn more about the science, how the Weather Service uses it, more about the imagery. But I'll send along a couple of links for you.
Okay, great. And again, if you can stay with us, we would love for you to do that and just hop in anytime you want to here, because we're going to kind of roll into a conversation about the Oklahoma event last night, how the warning process worked, and everything else. And I know that Neil, you got to head out here in just a second. So Neil, thank you for being here, and thanks for as always. And we still have to sort your voices out. This is very confusing. You guys are clones of each other. That's interesting.
Yeah, this was an awesome show. And again, keep up the great work, Scott. What you all are doing over there is awesome. But I got to bail. I'll share my pick of the week over email.
Okay. Sounds good, Neil. Thanks a lot. So let's just start with Kim. I know that Rick has been doing storm survey work, I think, today. As I understand it, Kim, Rick was in Durant when the event happened at an emergency managers conference, right? And then he came back and did survey work today. Is that the deal with Rick?
It is. And he just let me know that he is trying to log in. He's got the hotel Wi-Fi and government laptop thing going on, but he's going to be making an attempt. Oh, well, our Oklahoma James said that he'll be speaking there tomorrow. That's great. Well, man, this is, I guess, one of the more exciting Oklahoma emergency management conferences ever. So yeah, I hope that you have a good time. Yeah, it started on Sunday. And so this was a really exciting place for everybody to converge as they're watching their state go through, potential tornado outbreak. And from what I understand, Rick is, like I said, really trying to get on here, but we should ask him a lot of questions about what it was like, because it turned into a bit of an EOC, Emergency Operations Center there, and was pretty fantastic from what I understand. So just stall a little bit, because I really don't want to go on without Rick. But tell us, James, what will you be speaking about?
I'm actually doing the presentation, excuse me, on my master's thesis about tornado warning risk perception in Oklahoma and trust building factors for messengers to have their messaging be more credible. Oh, I see Rick.
See, look, we stalled it just long enough. He's going to make it. At least.
Yes.
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 Oh,
Guess
hey.
the hotel.
Yep, it's the hotel. Looks a little bit like Bill. How you doing, Rick? Are you able?
I am here. Can you hear me?
Loud and clear.
Hey.
All right.
5 by 9.
I knew that you were joining us, so I was stalling just a little bit because James asked about the conference that you're at and the intersection of that with this whole event, and no one could speak to that like you, especially in the days leading up to it and everything else. So let's just go right into it. Tell us the story. What has it been like? The forecast arc going into this event, and also knowing that this EM conference was coming up, and you were there yesterday with those people while this was happening.
Yeah, this is even for Oklahoma, and even for all we deal with, this has been a crazy week. Of course, we had I think we got introduced to the severe weather risk on a day 5 SPC outlook, which in and of itself, in February especially, generates a lot of excitement and buzz. And oh my gosh, they've only done this X number of times. So yeah, that was exciting. And then we began pretty quickly. We began earlier than we normally would, a series of webinars for the emergency managers, our partners. We started that early, mainly because of this emergency management conference. The Oklahoma Emergency Management State Conference is here in Durant this week. We knew that was coming up. We knew EMs were going to have to decide whether they should travel, what they were going to do about coming. So we started that very early. At the same time, we were also preparing a briefing package for the emergency managers at the statewide level, us with our offices in Tulsa and Amarillo and Shreveport. So all that's going on. And then that just progresses through the days leading up to it. So we're doing webinars every day. We're sending emails to our partners, and that just increases as the confidence increases and the sense of urgency increases just a little bit, trying to stay, kind of level and balanced. But then it gets to be, then it really gets to be crunch time for the emergency managers to make decisions, because they need to know, okay, this is a conference they've waited for all year. They've made reservations. Their people are scheduled to do presentations, just like at an AMS conference or anything like that. And they had to make decisions. So, I mean, it was really just trying to, even more so than normally, just trying to nail down that timing as much as possible. With this system, I mean, there were some things we're very confident in. We were confident in probably evolving into some kind of linear mode. With the big question, even up until that morning, was the moisture return, how deep the moisture was going to be. We knew the shear was going to be off the charts. And so the messaging of that, the confidence in most of the messaging was pretty good. That moisture return was the big question. So anyway, let's see. I'm getting my days all mixed up because I'll tell you about my last 24 hours here in a second. But Sunday morning, one of the forecasters and I, they do training days. So before the conference actually starts on Sunday and Monday, they do training so they can get continuing education. So one of our forecasters and me were teaching a FEMA course, a 12-hour course. We started that yesterday at 1, and probably we got through 20% of the actual course material. The rest of it was real life. Let's look at the weather now. Here's what's going on in NWS chat. The class was hazardous weather preparedness. So how could we not, take care of a real world, take advantage of a real world situation. So we got that done. We ended the class early, and then I don't want to keep talking too long. So flag me if I'm, you have
the floor, Rick. You have the floor.
We got all night.
So I've been to this conference many, many times, every single year since I've had this job. For the first time this year, they actually established an alternate state emergency operations center here at the conference. So it's complete with, they've got all the monitors, the 800 megahertz radios, the cool vest that you get to wear in an EOC, the credentialing, the scheduling. So we already had a schedule worked out where we and the Tulsa office are going to man this EOC for 12 hours a day, working 6-hour shifts. It wasn't supposed to open until Monday, but they decided yesterday to quickly spin it up because of what was coming, yesterday afternoon and evening. There's a bunch of emergency managers here. A bunch of them did travel, but a bunch of them were here and making the decision about whether to drive home for the severe weather as late as last evening. And we're telling them the storms are moving 70 miles an hour. You should have left an hour ago. But some stayed, a lot of them had already worked out contingency plans where they had people that stayed behind, but some came here. So we get in the EOC. There's Vivek from our office and me, and then Karen Hatfield, who's a forecaster in Tulsa. So we're all in the EOC. And it gets really official. I mean, they close the doors and say, you can't come in here unless there is official business or unless you really need to, it was really kind of they wanted it to operate like a real EOC. So, but the weather people are in there. And when the storms really got closer to the metro area, because we had quite a few metro area emergency managers here, I'd never experienced anything like this before. We were in the EOC. They would go out just outside the room where the EOC was, they had all these chairs, tables set up. It was like dozens of EMs were just sitting out there. They had huge screens with NWS chat on it, with radar loops on it. It's like, man, this is a weather geek's paradise right here. But as a community came under threat more directly, if the emergency manager was out there, we would call them into the EOC and give them very detailed briefings. So I've been joking to everybody. It felt like you're at the doctor's office. It's like you stick your head out the door and go, okay, Pottawatomie County, it's your turn. You're up next on the tornado train. Come on in. And it was almost like that. So we had, for example, the Norman Emergency Management Coordinator was sitting next to Vivek Mahali. Vivek is describing radar signatures. Even before our office was really gung-ho on him, he gave David Grizzle, the emergency management coordinator, several extra minutes to expedite the sirens activating in Norman and letting his dispatchers and some of his leadership know that this was coming, it was developing. So that was the big tornado of the day, the Norman tornado. Same thing with Galen, Kitch, and Moore. Same thing with Pottawatomie County and Shawnee, with Edmond, and it continued on through the evening. So I've never been an IMET that goes out on a fire, but to me, this was a different experience. It's a whole different world doing, we talk about decision support services. It's a whole different world doing it when the emergency manager is sitting there with you face to face and they're asking direct questions. How come this warning isn't being updated? Where are you going to reissue this polygon? We need to figure out what to do with sirens. It's a whole different thing to me when they're there, but it was such a wonderful experience. I just got back to the hotel here 30 minutes ago, and 25 of those minutes were spent talking to emergency managers in the lobby, telling us what a great experience that was. So that's a long story, but then about 11:30 last night, I got a call from my boss saying, in a very kind, understanding way, that I needed to come back to Norman to help with damage surveys, because we had stuff from border to border. So I got back to my room at midnight last night, got up at 5 this morning, drove to Norman. I surveyed damage continuously until 5 p.m. Immediately drove back down here and just got back. So if I fall asleep or start talking crazy, forgive me. And Kim already gave up on me, so.
At this point, I think we are just running as all co-leaders of this expedition. I was looking at Jen and whatever, but you know what, Rick, you and we're going to run this portion of things with the experience. So it's really interesting thinking about the perspective that you were getting down there watching this event. I'm curious, how did you feel as the day was ramping up about the forecasts and the kinds of messaging that were going out? And this is a good question for Oklahoma, James, too, because it was my observation that once the SPC really started to ramp things up, I saw the forecast office, at least in Norman. I hadn't seen the Tulsa stuff, but you can tell us about that, James. I saw the Norman office really ramping up the language too, and there was just a whole lot of concern about this event. So interested in your thoughts about that, just how that whole the ramp up progressed, because I think we'd all known for days that there could be a high-end event today, but it really, the hammer didn't come down on it until the day of.
I think really in our office, what really started to lock it in more was probably Sunday morning, starting to see some of the models starting to come into agreement, and starting to see the models actually handling the moisture return very well, and actually seeing the 60 dew points well within reach of southern Oklahoma before dark. So that had been one of the big question marks the entire time, where they was just holding us back a little from just really going all out. We're always trying to ramp up and not back down in our messaging. So it was a gentle slope upward, but yeah, I think it was the confidence building on that moisture return that it was really going to happen. And then, of course, we're following along with the SPC outlooks, and we pretty much just sharing those as they come. But I know I was driving down to Durant, and Vivek was reading me I guess it was the 1730 outlook, and I think it was Jeremy Graham's was really started hitting it hard, like a derecho. That was the first time that word got mentioned. We don't talk about those a lot around here. And then it just felt like the rest of the day, this is happening, and we just got to do everything we can. And I really felt like the emergency managers had been well informed. Nothing we were telling them on Sunday seemed like a surprise or, whoa, where did this come from? We had kind of been building toward that. So I don't know, James, what perspective you got from the Tulsa side?
It was the same thing. We had a lot of doubt Friday evening, because the cams were a little inconsistent with the moisture, and you could look at the MEDARs and see the deep moisture was still pooled way south in Texas and along the Gulf Coast. And, you can't help but look at it with a February perspective and think pessimistically, there's just no way we're going to get anything other than just this ankle deep moisture up here. But when the cams on through Saturday kept getting more and more consistent, and that's when the Tulsa office also started ramping up the messaging from a probabilistic discussion to, these probabilities are getting higher and higher and higher. And so by Saturday afternoon, we were already making our staffing plans ready to go for Sunday. I'm not normally working on weekends, but I told my wife at that point, yeah, y'all are on your own for dinner tomorrow.
Yeah.
Yeah, and I couldn't help but reflect, Rick, last week we didn't have the chance to debrief our WeatherBrains crew here and all of our listeners about the IWT that we'd held, just the week before.
Yeah.
And it was really interesting that there had been some conversations that I thought related really nicely to thinking about how to message, the events that were upcoming. And I don't know if you wanted to transition for just a minute to talk about some of the stuff that we covered in the IWT, and then I have some, I don't know, some things to comment on the messaging that was going on that I think relates to some of the stuff we were talking about in IWT. I actually think some of the things that we were talking about left that room and were implemented in this event, if I'm not mistaken. So I was really excited by what I saw.
Yeah, I mean, that was only our third full-blown integrated warning team workshop that we had, and I thought it was really, really good. We got lots of good positive comments on it. The EMs that I was talking to, just as I was making my way to my room, had been there, and they were commenting on it too, that was one of the best workshops. And not to brag on us, the workshop was made good because all the people there. We had about 80 emergency managers there, TV meteorologists from almost every station in the Oklahoma City market. We kind of centered this on central Oklahoma, but it was really good discussion. And yeah, I mean, it was very cool. I mean, pretty quickly, I mean, Joseph did the presentation on the challenges of the cultural differences and challenges with Spanish language translations and the weather information. And I don't know how many days it was later, but one of the TV meteorologists that had been a participant in the workshop for the first time ever is tweeting Spanish language graphics, not retweeting Weather Service Spanish language graphics, but somehow had translated some of their stuff into Spanish. And Kim and Cody and Joseph and I were all instantly like, oh my God, look at this. This is really, really cool. So that was one of the really tangible things. But I'm curious to hear what your other thoughts were about what other messaging things that may have come out of that workshop that found itself coming to life in this event.
One of the things that I thought was really interesting was just what I tried to cover with the audience was just how survivable tornadoes really are, and that we don't need to tell people ahead of events that are scary, which this event had a definite fear factor that was coming into play with the meteorological community. We don't need to tell people that they won't survive if they can't get underground. And so what I saw was this really nice arc of messaging that was really talking about the populations that we most need to focus on. And this is something in the Southeast you guys have started to grapple with, for years. You've been thinking about this too. People who live in mobile and manufactured housing, or just any structure that's not attached to the ground. But part of the issue is people just don't know how good structures that are attached to the ground are at saving you. They are remarkably good. So this is something that would be, I think, empowering to tell people. But just in the interim, at least to say the target audience is just this group. And if you can get to any permanent structure, do it now. And I saw messaging about, we've got about an hour. This is the time where if you're in this kind of structure, this is when you should be thinking about leaving. And there were just some really interesting innovations that were going on as the stuff was coming into, especially the metro area. There was that sort of focus where I think we probably have a larger number of people who live in those kinds of vulnerable structures. So
Mhm.
I'm just really excited to see that. And it was coming from all segments.
Yeah, it was cool. And I've heard this particular message before in events like this, but heard it on, while my wife was relaying information to me as I'm texting her, and she's a superstar last night getting our kids all to safety and the dog. And she heard the message on one of the channels saying, stay away from west facing windows. Well, the entire back of our house is west facing in our living room and have a big patio back there and everything. So she took action immediately based on that. We've heard that before, but that's another message. I see that as a message of, this is a little step you can take to greatly increase your chances to be okay in this. You don't have to freak out. My wife was not going to go out into the backyard with our 60-pound dog and try to get her into our twister style underground storm shelter in the backyard. It wasn't one of those days. So we know that, okay, well, alternately for these types of events, you're safe in there. So I don't know, that west facing window thing kind of strikes at that a little bit.
It does. I think we don't necessarily do a whole lot to help people understand, what they can do. We focus so much on just this, like, this is the most perfect thing is to get out of the way. But man, there are a lot of things you can do. And distinguishing an event where you're really worried about like a big tornado kind of situation versus this was never going to be the case for us. We were always, there might have been tornadoes that were long track. And that was in the cans, that was something that we sort of saw the signal of. There could be some longer track tornadoes with this, but they're always going to be embedded in these lines. And when that happens, there tends to be an upper level of what you're thinking about for intensity, especially with, the instability as it was. We knew that there were some limiting factors. And so it's one of those things where I was trying my best to message to people, especially as the way things were trending as things came into the metro. This is a time where you can just feel comfortable. I'm not even going to use the storm shelter. I'm not going to do the whole thing in the garage. I'm going to, we're going to duck into the bathroom if we need to. And these are probably going to be storms that won't have a lot of lead time. Like that's another one of these features. It takes time to get into that shelter, especially as many of us have them in places that aren't easily accessible. And it's really helpful to let people know there is something really good you can do. This is the kind of day where that is all you really need to think about. And I think people can get through it with just a lighter touch, a lesser impact on themselves. This day, while it was worrisome, it wasn't an April 27th kind of day.
No. And my wife is not a representative sample because she's, she has to live with me and listen to me all the time. But she really was a good gauge to me last night. I mean, she was comfortable with the situation. She was comfortable with the room that she went in where she took the dog. She wasn't worried about going to the shelter. She was ready to dive into a closet if she had to. But that kind of thing is really hard to message to just everybody. It's easy to explain that to my wife and friends and do it on Facebook and where everybody. But it's hard from the Weather Service, and I got to imagine from a TV perspective to message that, well, if this, then that, or, well, this kind of tornado you don't need to worry about. Well, how come not? And a tornado is just as bad as the other one. I don't know. But the important thing is letting people know. It's so important to let people know that not every tornado is equal. It's just a challenge to do that in a very short, concise way that doesn't confuse some people, if that makes sense.
I think part of that starts early. I know on severe weather days, I try to make a longer Facebook post on my work Facebook page. And the main crux of my messaging was, if you're in a mobile home, anchored or not, this is not the kind of situation you're going to ride out in the mobile home. And, you feel somewhat compelled to also say that mobile homes are great. My grandma had one. I weathered many a storm in it. But when the watch is issued, you can't wait for a smaller lead time on a QLCS tornado event to evacuate a mobile home and get to shelter. And so my messaging on that was, when the watch is issued, that's when you need to go hang out with a friend or family with a bigger thing. But I'm struck also by something that Kim told me in my PhD journey, and that was, don't let perfect be the enemy of good enough.
Yes.
I mean, perfect would be your underground shelter. And, even Moore and Joplin, the level of EF4 and EF5 damage is such a small percent of the overall damage. We're in really good shape in homes and just site built structures.
Yeah. And Kim, I haven't shared any of the feedback with you because I don't know. I've just been busy and haven't compiled it all yet. But I mean, overwhelmingly, one of the most popular things and eye-opening things from the workshop that people talked about was your talk about. I think people just didn't realize that. And I know you got a strong reaction from at least one emergency manager who was there that was very thankful for this eye-opening experience that you would give them, because I've been in a situation where it really does feel hopeless sometimes, that people are asking what to do and they don't really have a perfect option, and it feels hopeless for them, and it feels hopeless for the person kind of messaging to them sometimes. But I mean, I don't know if you want to talk about that, but that really was an eye opener for lots of people in the room, that I don't think they knew that, or they didn't. You've kind of given them the permission to think about that and message that, is kind of how I'm looking at it.
That's what I'm trying for, is to give them permission to not just say you've got to get in a FEMA rated shelter, but that they can feel a sense and measure of comfort in helping people to do the best thing that they reasonably can. And part of the reason behind that is, first of all, what most people can reasonably do is really, really good. Getting in any structure that's attached to the ground gives you almost perfect odds of surviving. It's crazy. And our field, we don't teach people this. It's not known. But even in the worst tornadoes that occur, over 99% of people typically survive the experience. The worst case that I covered, where we have any estimate of the fatality rate in some detail, is Joplin. And that was a slow moving, mile wide wedge where if you're in the middle of that path, you're under that thing for like 6 full minutes. And even in that worst case scenario of crazy level of decimation, 98.5% of the people who were exposed to it survived. And that's remarkable. We focus so much on fatality counts in our field that we do not do what epidemiologists do, where they look at survival rates or fatality rates. We're not looking at the base rate. We're not looking at how many people were exposed total. And it's not to say that this isn't a tragedy. It's not to say that at all. I mean, Norman, we didn't have fatalities last night, but there are a lot of people who are very traumatized. These things are difficult to go through, but it is very important for us to let people know so that they are motivated to act in their best interest. Let them know just how effective it can be to transition from one kind of structure to another. When you do that, they're actually motivated to take an action, because you can get to a point where you scare people so much that they're motivated to control their fear and anxiety more than they are to take action to actually handle the issue at hand. And so while we all kind of feel in our field like, man, I want to get people to the perfect, we have to recognize that we're messaging to people who live in imperfect circumstances. And if they can't access the perfect, and that's all you're offering them, then they might completely disengage and disconnect. And we don't want to run the risk of that. I think we're seeing some of the fruits of that in Oklahoma. We have people who flee in droves, people who leave perfectly good, well-built homes that would save them in almost every single circumstance that's conceivable. And they leave it to get in a car, basically a missile, for a tornado, to drive, perhaps not even knowing if they're going to go into the path of a thing or not, or hit traffic, or, just be really subject to the whims of the situation. And that when I covered in the presentation was, to me, that looks like emotion focused coping. That is people who are so dang scared that the only thing they can think to do is, well, I don't have an underground shelter. I've got to. And that's not okay. That's not okay for us to do to Oklahomans and people, in other states too, but it's certainly a thing here. It is definitely a thing here. And, we can do better. And so my hope was to just empower the audience with a little bit of knowledge about human psychology and about survivability. And the two things, when you put them together, it is just that phrase, James. It's, don't let perfect be the enemy of good. Don't.
Yeah.
So
it was clear that was the first time a lot of that group had ever heard that message. So I think that was the perfect audience and the perfect message for that group, especially as we get into spring here, and hopefully we'll continue to see that messaging softening in appropriate times and getting more realistic. I have a Post-it note with that saying on my computer in my office, so that's it's really important, and it's something we're learning. I mean, that's something even scientists and meteorologists haven't really gotten had a good handle on, but yeah, it's so important.
But if you go, go ahead.
I was going to say,
so go ahead, James.
I was going to bring in Liz Leitman's tweet. I guess y'all saw that, our friend from SPC who was on the show last week. But for those that didn't see it, she started by saying, it's blowing my mind that I'm seeing some people on here say Norman had no warning. Number one, this event was well forecast days in advance. Number two, NWS Norman issued the tornado warning before the tornado developed 10 to 15 minutes before it hit town. Sirens went off, cell phones and weather radio alerted. Just because the TV meteorologist was focused on Oklahoma City and not Norman doesn't mean there wasn't warning. Don't wait for the TV to tell you what to do. This is why we say have multiple ways to get warnings. So I just want to get all of our Oklahoma correspondents your thoughts on that tweet.
I'll jump in and just real quick. I commented on Liz's comment there. I've seen this happen. We had a hailstorm in Norman back in April of, I don't remember when it was, 2019, or in the last few years, a really devastating hailstorm in Norman. And we had the same kind of thing. I mean, people's cell phones went off. We had issued a warning many minutes in advance of the storm. But the TV, I think there was a presidential address. For some reason or another, the TV stations were not wall to wall. It wasn't a tornado warning situation. And to many people, it's not a warning unless the TV stations are cutting in and interrupting. In that situation, we heard from a lot of people saying, the TV meteorologists weren't on. That's how I know it's bad, if they're cutting in. So that's kind of this too. There's people that also have their preferred warning methods. If I don't hear the sirens, I've talked to people on damage surveys that knew there was a watch, knew there was a warning. They heard the roar, they saw debris falling out the window, but they sat on the couch waiting for the siren, because that is the heralding cry that the tornado can now enter the gates of the city. So I really think that's true. I've seen it in practice with TV meteorologists and sirens. And I mean, of course, that's not a good thing to do.
Well, when I did my thesis research and it was only Oklahoma residents, outdoor warning sirens were the number one preferred way people selected in that survey to get their initial notification of a tornado warning. And it's just,
And it's popular. It generalizes to pretty much the whole central region. It's one of the most popular ways to first get a warning. And I mean, I saw it in Alabama after April 27th, and I appreciate the discussion where, you hear this as an emergency manager or forecaster and you think, well, we've got to take the sirens down. I really don't encourage that. I mean, the thing that's so striking to me is I think sirens work better for most people than we give them credit for. I know they're designed to be outdoor systems, but here's an example. Here in Norman last night, we had sirens that went off in 3 waves. We had for the warning being issued, reissued, and then going, even though the storm had passed, it was still sort of part of East Norman, and those sirens went. When the East Norman sirens went, people in Central Norman still heard them, and they were even confused, like, why are the sirens going again? Did the storm pass by? Is it over? Like, that's how much sirens can actually permeate structures. And this is a very loud storm with a lot of wind. So I understand the discomfort this gives a lot of people, but I think we also have to understand we're dealing with a system where there's no single perfect thing to reach everyone. Although we're about to hear from Bruce where if everyone had a weather radio, of course, that would be the ideal perfect. It would never fail, and it'd be targeted. In what most people do in the real world is they have this sort of patchwork quilt of different things, and so anyway, I'm not surprised by that at all, as much as it might distress some people. We do have the reality is we have a large segment of people who use it. And so you have to look at that and say, are we just going to throw this away, even though it's working for so many people? I do want to say to Liz's point, every time I hear this conversation about the interpretation of people saying, I didn't get a warning, I sympathize with our community where everyone sort of says, but there was one. Like there was a button pressed, there was a polygon drawn up, then button pressed, then a whole dissemination system. All the warning existed, it went out, it was disseminated. And the thing that they're expressing is that warnings aren't just a technology, they're a social process. And so to them, they either didn't receive it or they didn't believe it, personalize it, understand it. Like they might not have really, really wrapped their arms around the fact that it was a threat that really did exist and was them. They're not necessarily commenting on, man, Weather Service, you didn't put a warning out. It's a broader, I think it's a broader statement.
Right. Their definition of what a warning is totally different from what we do in the weather enterprise. They're getting this, oh, this is news to me. No warning.
Our definition of a warning and how we verify it, by the way we verify it, we have no idea what the public takes as a warning that verifies. How close, like, does it have to be a tornado or not? How close do you have to be, fine with having been in a warning? Like all of that. We've come up with our own definitions for these things. And there are different definitions that colloquially are used. And so I encourage us to not take it as this harsh criticism of the system that, oh man, the Weather Service failed to do the technical thing. It's as much just a thing of either dissemination or their own reckoning with the reality of what happened to them. That, oh my gosh, there was nothing that prepared me for the fact that it was really me that was going to experience this. And, it takes some time to go through all of those stages of belief, personalization, like receipt, belief, personalization, and response. And with QLCS tornadoes, I mean, the thing that was difficult about the Norman one is we weren't watching it from counties away where the broadcasters were covering it. It was a lot of focus on the Mustang storm, which was fun. I mean, that was the one that existed earlier and it was heading toward a really populated area. And there really just wasn't that focus on that little bit of ephemeral rotation that then ended up becoming a big deal tornado. These processes of getting that risk information out do take time. So,
and no pictures, no video. That makes a huge difference too.
Yes, you're 100%. There's no confirmation coming in. So let's not take it too harshly. It's a thing. And every time it's said, I just try to have empathy for the people who are saying it. And we know what we did. And just recognize that, again, don't let perfect be the enemy of good. This might not be a perfect thing ever, but we can just try to understand what was behind it. It does say that. And that's how we can know how to try to do better in the future.
And I appreciate those comments because...
for me. So, yeah. Exactly right.
I was going to say, it's so easy just to attack people. And Liz did not do that, by the way. That's not the point of her tweet. But these people are morons. These people, and just blame it on the people because they didn't hear the warning and they didn't respond. And I think we've got to stop that attitude. We just can't be condescending toward the people that we serve. We have to have empathy, as you say, Kim, and understand and learn and be better at messaging these things. I just, in my older age, when I was a young guy, this is the first thing I think of, well, goodness gracious, it's their fault. We put out the warning. We were on television for 10 hours and they didn't do anything or they didn't hear it. Well, we need to be better at that. And I think that's what you're trying to say here. instead of getting our backs arched and want to just attack somebody, which is where we are in society today. Kim, what would you have done differently if you were on TV or if you're working at the Weather Service in Norman? What would you have done differently last night? We all, and again, we could all be better. So how could we have been better last night?
Gosh, it's tough. We were flipping around different stations, and I did see the potential for that rotation that could come into Norman, but in the hot seat, it's hard for me to criticize anyone. I mean, there was so much to cover. The thing with QLCS tornadoes is that they're ephemeral. They're hard to spot. James, James A, I think you might have some interesting insight on this, because one of the things you were trying to do was keep that potential covered for with labor, where people were kind of looking for those early signs of anything that might, become a QLCS spin up. You need a whole other set of eyes when something is possible. Why don't you tell us about what you guys do?
Yeah, and I think it's human nature to fixate. So we have a circulation spin up, pops a tornado warning, and that's the one we focus on, to the detriment of looking elsewhere on such a widespread dynamic event where we're going to have more of these spin-ups take place. So we normally do 2 key walls, 2 meteorologists, we tag team, and not at the same time. So it's 2 or 3 minutes for me, 1 or 2 minutes for whoever's tag teaming with me. That gives me a chance to look at radar too. But on big days like this, and especially QLCS days, we have a third person who only sits and looks at radar. And their job is not, once the tornado warning is issued, look elsewhere along that line. I'm looking for inflection points or any kind of little spin starting to happen. And that was great for us yesterday. Thankfully, it wasn't any worse than it was in my part of the state, but that certainly was very good to keep us from getting too just fixated on the strongest rotations.
It's a tough balance to strike. I think what you're doing with that model is about what you can do. Just try to be as aware as you can of the full scope of things that are going on. And, the broadcasters play a really special role in warning dissemination. We know that for tornadoes, it's still number one most consulted source of information is from you. And so people are watching before the warning's ever issued. They're watching what you're saying about things as they evolve, and they're anticipating then the warning. So, you're adding to the effective lead time in that respect.
And we were able to message some of those because Laura was the one doing that critical radar job. So she would say, okay, look at the little inflection point by Okmulgee. So on air, I can pan down to Okmulgee and say, this is a long way away from a tornado warning right now, but just to bring you into what we are looking at, we're kind of looking at this little inflection point on the line near Okmulgee. So if this continues to strengthen, it may require a tornado warning. It's a long way from that right now. So it really helped us with the process. And I think that's important, is that you share the process with people that are watching, because I think that builds credibility too.
Yeah.
Well, and again, I hate to break conversation here. We have to pause for our recorded segments here, but again, it's not easy. I mean, and the problem, you got these Monday morning quarterbacks all over the country, and they'll come in and criticize the SPC and the Weather Service in Norman and the TV guys. You have no idea what it's like working these things. I do. I deal with them a lot. Nighttime QLCS tornadoes that spin up really quickly, and there's hardly any lead time. And it's a challenge in messaging the whole thing and doing it right. There's no real manual on how to do this right. And so, but again, we have to learn from every situation, learn what worked last night, learn what didn't work last night. And I think this conversation has been very constructive. But having said that, we've got to pause, and hopefully Scott's still with us. Scott, if you're with us, we'll need a pick of the week from you. And this can be maybe some of the websites you talked about for the GLM stuff. But let's pause very quickly for Tony Rice and his astronomy report. We'll have This Week in Tornado History with Jen. We'll come back and talk with Bruce Jones. And we'll try and squeeze in a quick email segment, and we'll do picks of the week as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook. Venus and Jupiter finally come together this week in the evening sky. We've been watching them throughout February get closer and closer, and on Wednesday evening, March 1st, look to the west after dark for two bright points of light. On the left is Jupiter, and on the right is Venus. They're about half a degree apart. Also try stretching out your hand and put your pinky between them. That's about a degree wide. Both are bright and very easy to spot because they're both covered in highly reflected clouds. Though you could fit about 1,400 Venuses in a Jupiter, it's a lot farther away, so Venus is still about 6 or 7 times brighter than Jupiter. And that's something that really becomes apparent when they're this close together. Elsewhere in the sky, look for the waxing crescent moon to pass within a degree of Mars on Monday evening. Look nearly overhead for the sliver of moon next to orangey Mars. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, February 28th, 1987. The National Weather Service described this as a monstrous tornado. It developed just after 9 a.m. Central Standard Time, 2 miles south of Moselle, Mississippi. It grew rapidly and moved to the northeast at 60 miles per hour. 10 minutes after it formed, the tornado hit the Glade community, 3 miles southeast of Laurel. This tornado was given an F4 rating. For the storm data narrative, some homes were swept off their foundations, mobile homes were dismantled and tossed into trees. Glade Elementary School was demolished. The roof was blown away and both the inner and outer walls collapsed. Spectator stands supported the walls on the east and west side of the gym, and that was all that remained. There were 6 people killed in Glade. 4 deaths were in a mobile home. 1 death occurred when the victim tried to escape from a mobile home in a car and was slammed up against a tree. The other fatality was to a man who ran to a mobile home to help warn an elderly lady about the tornado. Before he reached the house, the tornado knocked down trees on top of him and he was crushed to death. Along the 35-mile path, there were 350 injuries. Read our complete summary about this event at tornadotalk.com.
Let's bring in Bruce Jones with Midland Radio. Bruce, looks like you were on the road again. Where you were located this week?
Durant, Oklahoma, for the Oklahoma Emergency Management Conference. Yep.
You and Rick are side by side in there somewhere, right? Rick, you got to be in the same building.
Our backgrounds kind of look similar. So yeah, we're probably, I'm on the 12th floor. Where are you?
15.
Oh, the 15th. Okay. I'm not that VIP. So.
Yeah. It's a huge complex. You may be in the other building over there. This place is, I've never seen anything like it. It's huge.
Huge. Yeah. I'll see you tomorrow.
So Bruce, what are your thoughts on the Oklahoma event since you were there last night?
Yeah. I was watching from Kansas City and then I drove through there today. And I was actually looking for wind damage and I don't know, I kept my eyes on the road. So I guess I didn't look close enough. I didn't see any real wind damage. There was one sign that was all kind of bent up and busted up and the letters were all gone. But then I realized it's an old Kmart sign, been there 12 years.
So looking back at the warning process, we say this over and over, and I believe it to be true. The baseline has to be a weather radio. And I just wonder what percentage of homes have them. And I don't have any firm research on that in certain markets, like in Oklahoma City or in Birmingham. I don't know, but I know it's stunning how many people don't have one of these things. And that would have solved so many problems last night if everybody had one.
Yeah. And, I think that Kim has touched on this kind of frustration of we do everything that we can and we hope that people get the message. But gosh, I agree with you, James. These radios have been around a long, long time. And it's still shocking to me that even in the midst of Tornado Alley, you have a lot of people who either don't have one or really haven't even heard of them. And I feel like, how could you have lived in this area of the world for your entire life and not have heard at one point in time someone talking about having a weather radio? So, I agree. Everybody needs to have multiple and redundant ways of getting these messages, but I've always been a huge fan of the NOAA Weather Radio Network, and I work real hard to promote it on behalf of the National Weather Service to try to build their audience, kind of like you do with a FM or AM radio station. You have a great product, and then you have to go out and promote that product and let people know that they can hear this really great station. And the really great
And-
station is NOAA Weather
And
Radio.
I just think it's so important to stress again that this has nothing to do with the cellular network, nothing to do with it. Where so often in a true tornado emergency, cell service just stops working. This fancy phone where you think you're always going to get the warnings becomes a brick, and weather radio keeps on ticking.
Yep. Yeah. Most of the weather radio transmitters, the antenna is up on a TV tower. So it's guy wired. These are big guy wired towers. And, occasionally one of those can come down, but it's pretty rare really for a guy wired TV tower to come down. You need a big ice storm or something major. So it's a very robust network. It's 1,033 transmitters nationwide. We even have some transmitters that broadcast entirely in Spanish, in the Spanish language. I just got some calls today from emergency managers in California after all the wild weather they've had out there, interested in doing some weather radio outreach. So the devices have been around a long time. If you're a listener to WeatherBrains, or if you watch the podcast on video, please do your part and let's do some advertising for the National Weather Service and for this wonderful weather radio network that they operate 24 hours a day, 7 days a week, 365 days a year. This free broadcast comes to you. And all you need to do is have a little gizmo that'll kind of decode it for you. It's a weather radio. If you go to midlandusa.com, we have a special for you. If you're a fan of the show, use the promo code SPAN25, SPANN25, and you can get 25% off any weather radio at midlandusa.com. So again, it's midlandusa.com. You can get these emergency crank radios. They're good if you live in a hurricane zone where you might need to evacuate. They're also good for wildfire zones, again, where you might need to evacuate. Or if you have an ice storm and we were without power for days or a week or so, it's nice to have a crank radio that you can use to generate electricity and help recharge that smartphone. And then those desktop weather radios, you set those just to go off for your county. And now with partial county alerting coming out this year, some of our counties are actually going to be partitioned into smaller sections. And you can tell your radio, I live in the northwestern corner of Adams County, and I only want to hear warnings for the northwestern corner of the county. And we'll be able to do that for you. Well, the National Weather Service will. So go to midlandusa.com, use the promo code SPAN25, SPANN25 to get 25% off. But most importantly, please help us spread the word about this life-saving network. The broadcast is free. The devices that listen to it are very inexpensive, and they work just like a smoke detector. You set them up, you plug it in, forget about it. But one day, that weather radio is going to go off and alert you to something that's of vital importance to you and to your family.
Absolutely. So again, NOAA Weather Radio, midlandusa.com. Look, we're for folks down here in the deep south, we're coming up on March. I mean, this is the 27th of February and April, and we all know what can happen this time of the year. So that is a very critical investment for you and your family. But really quick, let's dive into the email inbox and see if by chance we might have an email or two this week.
Letters. We get letters. We get stacks and stacks of letters.
All right, real quick, this is from James Lewis. If you thought messaging QLCS tornadoes was difficult, try messaging what happens when there's a bust. So James, I thought maybe you could just tackle real quick. He asked the question about the recent enhanced risk bust in Alabama. Why did the severe weather event not materialize? Is it due to something predictable or something that only became known very close to the event? It may be better to have a bust than an event that greatly overperforms, but I would imagine it's still very inconvenient with the disruptions to commerce and such.
Yeah, and again, people were very agitated with that, and it hurts. It hurts all of us when that kind of thing happens. And somebody said they wanted to stab me in the heart. I mean, I got some nasty ones after that. But some businesses close and schools close, and we all know that's a topic for another day. But it's parents have to leave work and go get their kids, and it's very disruptive. And we didn't have a single warning of any type, to my knowledge, not even a severe thunderstorm warning. And in a situation like that, the wind dynamics were just not strong enough, as opposed to what our friends in Oklahoma had last night, which was off the charts. It was much weaker than expected, and the instability typically is somewhat marginal with all the cool season events we have. And again, it's something you have to go back on and review and try and put in a system where it doesn't happen again. But the thing I've said over and over is that humility is missing in this science. We're going to get things wrong. It's happened before. It's going to happen again. But we just have to learn from this mistake and move on, which hopefully that'll be the case.
Yeah. And weather is hard. It is really hard. And
predicting the future is hard. You don't believe it?
Yeah.
Fill out a March Madness bracket. Let's see how you do. Okay.
Exactly.
Yeah.
Let's we'll get this from Steve Holmes real quick. National Weather Service Tulsa said a severe storm moved at 105 miles per hour. Was that a mistake, or was that for reals? Has that ever happened?
I'll defer to our Southern Plains friends here.
Yeah.
We had storm motion in one of our warnings last night of 95 miles an hour. So
Yeah.
Okay.
and we checked it once, checked it twice. So it's crazy, but yeah, I think it can happen.
Yeah, that's
When you see
insane.
my photograph and the picture of the week, you'll understand why these storms were doing what they did.
Okay.
Ridiculous.
Yeah, check that out, and you will get all that. Picks of the week gets all put in our post. And we also have a newsletter that comes out every Thursday. We give you a recap of the show. We get to talk about what happened, and we have some great articles coming out. That this week's me, so I can only get mad at myself if I'm late on the newsletter article this week. And we have that coming on. And then also, if you want to send us your email at weatherbrains.com. We really appreciate it. We try to read all of them, and we appreciate all of your support and just watching us every week. Thank you, everybody. Back to you, Span.
All right, so let's do picks of the week. We're going to go around the horn here. Everybody share something that is weather related. So James Adelot, you're coming up on a newscast here. So let's start with you. You got your photograph?
Yes, I've got my photograph. Norman sent up a special sounding at 3Z, which likely meant it was maybe an hour before the tornado. That was on the other side of the parking lot, basically, from the balloon going up. And the photographs are just crazy. I had sent out kind of a tweet in jest with the Jaws picture. We're going to need a bigger boat, that we're going to need a bigger photograph. But I mean, they were the wind vectors plotting on this photograph were so far away from the center. And that gave us a storm relative helicity of above 1,000, 0 to 1 kilometers. It was just filthy.
And one other quick thing about that sounding, the inversion that's on there. We had emergency manager saying, well, I heard there's going to be a cap that's going to weaken the storms. If you look at that inversion, it looks like that's pretty stout. Storms did not care one thing about it.
Yep. All right. And again, all the links will be up on the website, weatherbrains.com. Rick, while you've got the horn here, give us your pick of the week.
Yeah, I know this has been a pick before, but we shared it on our Twitter today, and I think it's important to keep sharing this time of year. The NSSL, the project that Kim's involved in, the Tornado Tales map, where you can go on a website, and if you were in a tornado warning, if you were in a tornado, or even if you just felt like you were in a storm where you were threatened by a tornado, real quick and easy survey to kind of share your experience and help social scientists and physical scientists learn more about how people respond to tornado warnings. So that's my pick.
Awesome. All right, let's stick with Oklahoma. Let's go to Kim. Kim, what you got for us this week?
Sure. My pick of the week is in two parts. There are two tweets. One, Rick, was your office, where I just loved how you guys handled right after the tornado passed through Norman, which, by the way, meant it passed about a half mile from the National Weather Center where the Norman Forecast Office is housed. They just tweeted out, "It's been a day." And I just that was awesome. Oh my gosh. But opposite that, there was some member of the public who tweeted out something about, man, well, Norman got hit. Usually it's more. This has to be the first time in my life. And this person was not like a zygote. You know, this was a like grown man. The first time in my life that Norman's been hit. And I just went, oh, why this belief? Why this belief? That the tornado crossed Highway 9, probably no further than like 100 yards from where a tornado crossed Highway 9 on May 10th, 2010, and went to the same part of East Norman, and we've built it up since then. So there was more stuff to hit than we had in 2010. But oh my gosh, it was such a similar path, at least early on. And we've had so many tornadoes, just so many on the east side of town over the last, I think there's been 4 that have come within 2.5 miles of my house since I moved here 5 years ago. I'm in Norman. Like I'm not even outside the city limits or on the fringes. Like I'm in East Norman, but that's still Norman. It's like no one thinks of East Norman as actually Norman. And so I lift my fists in rage. The end.
That's a fist shake. Yes, a fist shake. All right, Troy, give us a good pick of the week. Go.
Been busy here tonight. I apologize. A lot of stuff going on in classes this week, so I'm trying to take care of all that. Hey, I want to give a shout out, and I've supported the webpage for this to Phil Grigsby and the folks at the National Weather Service office in New Orleans, Baton Rouge. This weekend had the opportunity to attend the 2013 Gulf Coast Aviation Weather Workshop. They were holding it there in New Orleans, and a lot of folks there. Our friend Paul from NTSB was there. The airlines Delta and Southwest were there. Southern region folks. The folks in the Tampa airport, a lot of folks from general aviation, drone pilots. This was really a great thing that Phil and his gang at the Weather Service at Mobile and also at Tampa helped to put together as part of a series over the Southern Plains they do for aviation safety. Very good job, Phil Grigsby and all the folks involved with the National Weather Service, New Orleans, Baton Rouge.
Awesome. Good deal. All right, Bruce, give us a good pick. Go.
Well, every time I come up the Kansas Turnpike, I remember the KSN TV news crew that was underneath the overpass there and shot the video there. So I'll just let you know that's bridge number 84.027. That's the mile marker. Wow. 84.027. So if you're going from Wichita to Kansas City, you're going to pass through Andover. This bridge is 25 miles east of Andover. This was the second tornado of the day, but it's bridge 84.027. And I just emailed you, James, a picture of the bridge so you can put it on there so that everybody can see where it was. They were on the south side up underneath there.
Well, what year was that, Bruce?
That was 91, April
91. Wow.
26th of 91, I think. And yeah, I'll tell you very quickly the story because I interviewed the photographer. KSN was in Kansas City covering a news story. They're driving back to Wichita. They're coming down the Kansas Turnpike. The radio comes on. They said, Andover just got hit by a tornado. And okay, we'll continue to Andover and we'll get down there. Well, now they see this thing coming toward them. It was the second tornado of the day. And as they get under this overpass, they see there's a lot of cars under there with out-of-state license plates, and people are standing outside their cars not knowing what to do. And some of these were families. So the TV crew stopped just to help these people, some of these out-of-state people who had no idea what to do because here comes the tornado. And the photog, being a photog, grabs his camera and rolls video, and the rest is history.
Oh, yeah. That's some classic video right there. Awesome. That's a great pick, Bruce. Thank you. All right, Jen, go. What you got for us?
So I'm very excited to state that we have put out our first long form video in 3 years, and it's actually 37 minutes long. And we realized that we have these wonderful summaries that we can just go ahead and put them to video and maybe reach a bigger audience to let people know about these amazing events that, you know, they're tragic, but they're also hopeful, and we get to tell the people story. And so we told the story of the Barnesville, Georgia EF3, April 28th, 2011. It was written by Nelson and I, and then I brought Dan back, who is my original co-host for Tornado Talk and my boss, and he narrated it with me. And so we just took it straight out and read the story back and forth. And then I produced a video with all the radar and imagery and stuff and told the story, and there's music as well. And so I really hope that people enjoy it. And it's going to be the next phase of Tornado Talk. We're going to continue to have writing. We're going to continue to do and then produce these videos to hopefully tell the stories even more. So that is my pick of the week. It's on YouTube.
And the storytelling is just outstanding. It is really good. So be sure and check that out. All right, Scott. So we have stalled long enough, and thanks for staying with us for the extra hour. Hopefully you're not sound asleep by now, but Scott, give us your pick. Go. And maybe Scott did fall sound asleep. You might be muted, Scott. Or did we lose him? I see he's there.
He's there. Video is there.
But his mouth moves and there's no sound.
Yeah. Well, maybe the batteries on the little ear things have died. I don't know, but if he's hearing us, then the mic should still work. Well, anyway, Scott has sent his pick in the chat room here. Longest lightning flash ever? ? And it's a story map. And again, we've got the link, and we're going to put it up on the website, weatherbrains.com. So Scott, try it one more time. No, we just can't. We can't hear you. I'm so sorry. But anyway, Scott, thank you so much for the first hour in the discussion. Again, it's just, to me, like I said before, it's a treasure trove of information. It's absolutely fascinating the work that you're doing. So thanks for your work, and thanks for being on the show tonight. And having said that, we do have to wrap this one up. We're at the top of the hour. We have hit 2 hours here. If you are new, we typically record Monday nights at 8 o'clock Eastern, 7 o'clock Central. A lot of people watch us live. We're on YouTube, youtube.com/weatherbrains. But we know that most of you listen. However you consume this, thank you. If you want to get in touch with us, the email address, it is email@weatherbrains.com. You might have some thoughts on the various topics we talked about tonight. So send us a note if you want to. But on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless. Thanks, everybody. Scott, again, thank you. That was a great segment.
Thank you, Scott.
Awesome.
Yeah. Thanks, everybody, for
Everybody.
Oklahoma
Good
crew.
week.
Y'all have a good week.